Hey everyone, this video will introduce you to the birthday problem as well as give you an explanation into how to solve it. The birthday problem asks that in a group of n chosen people, what is the chance that some pair will have the same birthday? If the problem is done correctly, you'll find that in a group of 23 people, there's a 50% probability that a couple will have the same birthday. And in a group of 70 people, there's a 99% probability that this will occur. Now explain how to solve this problem. First, let's let P of n represent the probability that some couple will have the same birthday in a group of n random people. We know that there are 365 days in a year, thus there's 365 unique birthdays. So the chance of a person having the same birthday as another person is 1 over 365. Now that we know what P of n is, we know that P of 2 is the probability that two people will have the same birthday in a group of two people. And this, of course, is 1 over 365. In this birthday problem, only two events will occur. Either a couple will have the same birthday, or there's nobody in the group that will have the same birthday. So P birthday match plus P birthday don't match equals 1, which is 100%. If we move P no birthday matches to the right hand side, then we get this equation. And for simplicity, we just let P of n represent P birthday match exists. Getting back to P of 2, which is the probability that a couple will have the same birthday in a group of two people, we have P of 2 equals 1 minus 364 over 365, which is 1 over 365. Now 364 here is the number of days that do not share the same birthday as the first person. So for example, if person 1's birthday is on May the 1st, there are 364 other days in a year that is not May 1st. In a group of 3 people, it would be P of 3 equals 1 minus 364 over 365 multiplied by 363 divided by 365. The 364 over 365 here is basically P of 2 no birthdays match. So it is the probability that no birthday matches when there are two people in a room. However, now that there's three people in a room, that means two other people have different birthdays. This means there's 363 other days that do not share the same birthday as the first two people. And the reason we multiply these two numbers is because both these events must occur for there to be no birthday matches. In a group of 4, we just multiply by 362 over 365 at the end. So 362 here is the number of days that do not share the same birthday as the first three people. And this trend will continue for n number of people in a group. And we get this equation here. So for this equation, this number here is basically 360 over 365. This here is this number, this here is this number. And we multiply all the way to 365 minus n plus 1 over 365. The reason we have minus n plus 1 instead of minus n is because we start comparing birthdays when there's at least two people in a group. So if we look back to P of 2, which is 1 minus 364 over 365, it's actually, the 364 is actually 365 minus 2, which is n, and then plus 1, which makes it 365 minus 1. Before we continue further, we need to know what a factorial is. Factorial is denoted by the exclamation mark, and it is the product of all the numbers from 1 all the way to itself. So here we see n factorial is equal to 1, multiply all the numbers up to n. Now for the probability that no people have the same birthday, let's take the numerator and try to write it in terms of factorials. So we have 365 factorial over the factorial of 365 minus n, and we get the right hand side. Notice how the numerator contains all the numbers that is in the denominator. So we can cancel out 1 here, 2 here, 2 here, all the way up to 365 minus n. And what is left is this number here. Now after some reordering, we can see that the number here is almost identical to the numerator for probability that birthdays do not match. Now the only thing that's different is this extra 365 here. Now let's set aside our numerator for now and focus on the denominator right here. Now notice how 365 multiplied itself n minus 1 times. However, since our numerator here has an extra 365 compared to the numerator here, let's just add an extra 365 to the denominator to cancel it out. So instead of 365 to the power of n minus 1, we have 365 to the power of n. All we have to do now is combine all the equations that we've been working on. So we get p of n equals 1 minus 365 factorial over the factorial of 365 minus n multiplied by 365 to the power of n. And this will be the general formula to solving the birthday problem. So if there's 23 people in a group, all we have to do is plug 23 into n, and we get that there's a 49.3% chance that no birthday matches, and there's a 50.7% chance that a couple will have the same birthday. And in a group of 70 people, there's a 99.9% chance that a couple will have the same birthday.